I want to talk to you about key features of functions. Some of these you know, some of them are going to be new, some of them are built upon things that you already know. So, whenever we look at a graph, there are certain parts of it that you need to know. Two of them we've already discussed, well, sort of. We, we know what the y-intercept is. The y-intercept is where the graph touches the y-axis. That's not bad. And if you look at this problem, you will see at this particular graph, you will see that that occurs right here. So for this problem, the y-intercept is 0, 2. I guess another point that I should mention is this. The y-intercept, it's also the value of y when x equals 0. So sometimes you are going to be asked to name the point for the y-intercept. So this is what it would be as a point. But if I just want the value of y when x equals 0, I would say the y-intercept is 2. This is how we've discussed it whenever we've discussed graphs. This is if they ask you for an order pair. It just depends on what they have. So be able to know both. So building on that, we know that the x-intercept is where the graph touches the x-axis. And for this one, it's the value of x when y equals 0. And this one actually has 3 of them. So there is an x-intercept here, an x-intercept here, and an x-intercept here. So those points are, we'll go least to greatest. 1, 2, 3, 4. We have -4, -1, 1, 2, 3, 4, 5, 6, and 6. And again, we could say those are the ordered pairs -4, 0, -1, 0, and 6, 0. Now we want to talk about intervals of increase and decrease. The intervals of increase, these are the values of x when the graph, oh my goodness. These are the values of x when, we could say the graph or the values of y increase. It's also where the graph has a positive slope. So if I look at this graph, I can sort of see where it's broken up into parts. I can see here. You know what? Let's just trace this really quickly. So you always want to start a graph from left to right. So from the left, we notice that we're going to go up this slope, but then we turn around and go back down. Then we're going to curve up and then curve back down and then slope down again. So if you look at all of the different places where we change direction, there they are. So it looks like for this graph, we're increasing here. And notice that the x-coordinate gets smaller. So for this particular graph, we're going to go from negative, We're going to go from negative infinity to, what is this? 1, 2, 3, to -3. That's where we increase. Then we decrease. Then we're going to go up again from -1, x is -1, to 1, 2, x equals 3. So one way to write it is a nested inequality. I could say x equals negative infinity to x equals -3. which is sort of here. We'll go and put an equal sign there if you want. I could also say it's increasing from x equals -1 to x equals 3. So I could look at either one of those. And just so you know, down the road, we're going to talk about interval notation. I'm going to include it on everything just so you're exposed to it. But the way interval notation works is you look at the lower bound of x and the upper bound, and this one goes from -infinity to -3. And when I touch -3, I'm going to put a bracket. And this one goes from -1, to infinity. We touch -1, we touch 3, but we'll talk about that another day. And now the intervals of decrease. Where are we going downhill? Well, we're going downhill there. Oh, let me give you the definition. My bad. These are the values of x when the graph, or the values of y, decrease. It's where the graph has a negative slope. The values of y, where the graph has a negative slope. So when I look at this graph, I see I'm going downhill from x equals -3 to x equals -1. So even though I'm touching this point, I don't want you to be focused on the y coordinate. You need to be focused on the x. Look where my dotted lines are. So when x equals -3 to x equals -1, my graph is decreasing. And then my graph decreases from x equals 3 to here. And what's this x coordinate? 1, 2, 3, 4, 5, 6, 7. So for me, it looks like we're going to go from -3 to -1. And then we're going to go from 3 to 7. So if I wanted to use interval notation, I'll say my lower bound is -3, my upper bound is -1. I am including the x's, which is a closed circle, so I'm going to use brackets. Oh goodness, that's a +3. So the other place where I'm decreasing has a lower bound of 3 and an upper bound of 7, and I'm including those points as well. Average rate of change. This is nice. Average rate of change is just an umbrella term for you. I want you to think of the slope. Think of it as rise over run. Think of it as, if you can't remember rise over run, remember your slope formula. And I guess we should also say that my rate of change for us will be m. It's a slope at a particular point. So what I could do is, when I look at this problem, if I wanted to go from if I wanted to go from x equals -4, here, I'll put this off to the side. Let's say we go from x equals -4 to x equals -3. What's happening? Well, I'm going to rise up 3 and run to the right 1. So for that rate of change, 3 divided by 1 is 3. And we actually will say the rate of change is 3. All that's saying is, as x increases 1 unit, the y coordinate increases 3 units. And the reason we actually don't call it slope is because slope is slope is a measurement we use to talk about lines. But look here, that ain't a line. This is a curve, but it still is going to have a rate of change. So if I look at the rate of change for, what is that? X equals 3 to x equals 6. All I want to do is look at this point here and this point here, and I traveled 1, 2, 3, 4. I'm going to go down 4, and then I'm going to go to the right 1, 2, 3. So my rate of change from 3 to 6 is -4/3. So rate of change is how do the y's change related to how do the x's change. But whenever we want to talk about the rate of change of a line, that's when we call it the slope. So let's look at a few more definitions here. So for rates of change, we say that the rate of change is constant when the rate of change is the same throughout the whole interval or throughout the graph. And what you're going to look for is basically a line. When the rate of change is variable, the rate of change changes at different intervals. Okay, that'll be a broken line. We go from positive to negative to positive. It could be a curve. So we'll call this a broken line. We also have to consider a curve. So if you look at this graph up here, it's constant for just a minute, but once we throw everything else in, notice it changes all the way around. So this graph up there has a constant rate of change. So, and I named it h of x. So we're going to say h of x has a variable rate of change. All right, so now let's look at some miscellaneous problems here. So when I look at this graph, I need h of 7. h of 7, I am asking for the value of y when x equals 7 on the graph. Okay, so what I'm going to do is I'm going to look at this graph, and we said when x is 7, what is the y coordinate? So here's 0, 0. I'm going to go 1, 2, 3, 4, 5, 6, 7. So x is 7 is here. Where's the point? The point is right there. And what is that ordered pair? That ordered pair is 7, -2. So when x is 7, y is -2. Therefore, h of 7 equals -2. And because I want to make sure I've covered everything here, I'm going to say h of 7 equals -2. Okay, now h of x equals -3. When what? Now for this one, they're asking for x when y equals -3. So let's take a moment here. In this one, they're giving you the input, asking for output. So for the top one, giving input, and they're asking for output. In this one, they're doing the inverse. They're giving you the output while they're asking for input. So let's find the value of x when y equals -3. So y equals 0, y equals -1, y equals, all right, so here is where y equals -3. And the only place it shows up on the graph is right there. Actually, let me just draw that as a point. What is this order pair? This order pair is 1, 2, 3, 4, 5. It's -5, -3. So they're telling me they want to know the value of what equals -3. So if -3 is the output, -5 is the input. Therefore, h of x equals -3 when x equals -5. And as x goes to -infinity, left on the x-axis, what does h of x do? Okay, so we're talking about, this is called end behavior, and y'all are going to love this. The reason it's called end behavior is we're asking what happens at the end of the graph. So let's look at the graph while I read the question again. As x goes to -infinity, what does h of x do? So here's what they're asking. As this graph goes to -infinity, that means it goes further to the left. Because remember, this is -5, here's -6, -7, -8, -9, -10, negative so on. What's happening to h? Well, h is also, they're asking what's happening to the y coordinate. So let me try to rephrase all of this. As the x coordinate gets smaller, decreasing, what's happening to the y coordinate? Well, the y coordinate is also decreasing because as we're going further left, we're going further down. My y coordinates also get smaller. So as x goes to -infinity, h of x goes to -infinity also. As the graph goes left, so I guess it goes lefter. It also goes down, more down. Let's not put that in there. So that's what we're talking about with end behavior. The domain, remember, is the set of all x's. That's whenever we talk about just a collection of points, but it also works for a graph. For a graph, which is a continuous set of points, I want you to think of it as how far to the left to how far to the right. And let's go ahead and talk about the range because we can fill both of those in at the same time. The range, remember on our notes, was the set of all y's. That's for a discrete function where I give you just a particular set of points. But when we talk about a continuous function, I want to know how far down does it go to how far up does it go. So let's look here at the graph. How far to the left does this thing go? Well, look at this point. Well, it looks like it's going to -infinity. Well, Robodeer, it's pointing down. Yeah, but as it's pointing down, it's also left. So see how it keeps going lefter and lefter? So my leftmost point is -infinity. How far to the right does this go? Well, it stops here. And the reason I know it stops there is because there's not an arrow to tell me to keep going. This is the end point. And what is that x coordinate? 1, 2, 3, 4, 5, 6, 7. So it looks like my domain, I'll put the domain here for now, my x value goes from -infinity to equaling 7. You can never touch infinity because you'll say, oh, the biggest number is 1 billion. I can just say, well, it's -1 billion and 1. And someone else will say, well, it's -1 billion and 10. And we will just keep going. We never touch -infinity. But notice with the closed circle, we do touch 7. And now let's look at the range. How far down does this thing go? Well, it goes down forever. So my range goes from -infinity. How far up does it go? Well, the highest point is right here. The highest point actually has a name. It's called a maximum. Oh no. 1, 2, 3, 4. So it's an adjective that's also a verb. And this goes to 4. So the width of my graph is -infinity to 7 because those are my x coordinates. The height of my graph is -infinity to 4. So, and if I wanted to do the interval notation, my left bound is -infinity. My right bound is 7. Since I can't touch -infinity, I'm going to use a parenthesis. Since I can touch 7, I'm going to use a bracket. For my range, My lower bound is negative infinity, and again, we don't touch it. My highest y coordinate is 4, and I can equal 4, therefore I use a bracket. So it goes to the left and forever, it goes to the right, it stops at 7, goes down forever. The highest that it goes is 1, 2, 3, 4, and there it is right there. So my domain, the set of all of my x's go from negative infinity all the way up to 7. And remember, we'll do interval. My y's will go from negative infinity all the way to 4. And this is negative infinity to 4 inclusive. My bad. There it is. So what am I asking you to do in key features? Well, let's look back at the graph. All I want to do is analyze the graph. I don't want you to be able to tell me everything that you know about it. I know it goes to the left forever. The rightmost it goes is 7. It goes down forever. The highest point is 4. It has 3 x-intercepts where it touches the x-axis. It has 1 y-intercept where it touches the y-axis. We have the graph increasing, decreasing, increasing again, getting to sort of a high point, and then decreasing some more. So those are the different things that I'm going to ask you about it. I will also ask you about average rate of change. So just be ready.